And running and good, it looks like. Okay. So, hello, scripters and kitties. We're gonna wait a little bit, see if see who wants to drop in. This one's gonna be a little bit more different than the last one we had. We're gonna do a quick recap, plus go over, not necessarily go over the last video. The last video was an art stream, but we will be going over a couple things like singletons and execution order. As well as what I'm going to do moving forwards with some of these other types of things here that we'll be looking at. So, we'll give it a minute and then we'll get to that. I'll switch you over to the document view. Look at our document. I haven't really added anything to this currently. Still just kind of sitting and looking at it. A little bit of documentation from last stream, where we went over some pixel measurement and just concepts of image size and what we actually need to make our game projects, as well as some AR, VR type things. And we'll probably just be going, give me a few open lines for there, and we'll be looking at some stuff there. But we'll give it a couple minutes here. So that the stream gets a little more stable. There we go. Okay. So we haven't touched anything with the states since we covered acceleration, and we got acceleration set up to do some stuff based on our settings and our parameters. We have to do wheel rotation, jump, and some other stuff that we'll talk about getting into today. Lighting, we still won't be touching lighting for a little bit yet. We'll be looking at race progress sometime in the near future. And track placement, we haven't done that. Racer start placement. This is something we'll be working towards also looking at soon. We'll look at this right before race progress probably. And then we have finish celebration. That'll probably be way towards the end. Full cycle. We'll start developing that game cycle here soon. And we have save data, which we'll talk about later. And this set we're not anywhere near looking at yet, but talk about how we're creating structure for that in mind later. I'll go, if I can change over to my code, I'll take a look at my code. Input bridge should be pretty well set up, and accelerate you'll see inside accelerate racer. We had the add force here, but now we're using the ARMC accelerate SCO acceleration. So the acceleration parameter on the scriptable object that is in the racer move context in this section here. Okay, so for after, we can probably start looking at some of the stuff. So, things that we need to talk about today are singleton. If you were on the last stream or watched the last video, you'll see that we did in fact make a C#. C# singleton. It was basically, it took up like 3 lines. It's a private constructor and a private variable with a public getter that makes an object if there isn't one. So that way there's only ever one because everything's stored statically. I'm not going to cover that one again today. That one's in the other video. But we do have C#. So that one's the easiest one. And the reason I use that one a lot is because if you have a regular C# class that's referenced to something else, because it's just C#, once it's no longer used, it gets destroyed with cleanup. So we don't have to really worry about how that lives in our scene or when we need to destroy that one. But then there's a couple other ones that I'll show you today, and we'll switch you back to the document cam. So we have the singleton and we have C# one. Okay. Next one would be what I would call a getter. And I'm sure there's probably real names for these things, but that's kind of how I think of them. There's one where the getter can do it. And then there's also one where we can simply use awake. So the thing about this one, we can make it so that it constructs an object. So if we don't need a complex object with a bunch of references to other parts of itself, like other scripts that need to be added or something, we can do this pretty easy. If we do need references in like some sort of prefab or something, then we can do basically use the awake method to make sure there's only one of any kind of object in the scene. So a singleton just means there can only be one, and we make a pattern in a way that creates only one object. Okay, so that's important because we own some information we only want in certain places. So let me pull up my okay. So I want to get my code transition here. So let's take the document view down. So what I eventually landed on when I was playing around with this, we're just going to talk over because I don't. Trying to code some of these connections is still kind of new to me, and I'm not going to code those live again. So what we have is essentially a game mode. Okay, so we have 3 classes. We have game mode, we have game manager, and we have race manager. Now, first I'm going to talk about the game manager and just work my way down that. So we have similar to the C# one, we have a static private game manager instance that is not set to anything, so this is equal to null. Then we have a protected racer input bridge. This is not used right now. You don't need this yet. And protected racer settings. Ignore that for now. This instance is only part of the pattern we're using currently. Or the only thing we're using currently. Public racer input bridge. Racer input bridge is get, so I commented out the variable, so I need to comment out the accessor. And then this is specifically for the singleton. So this instance as a variable, and then this accessor, this get in the accessors. So we have static, so we're setting statically public game manager. So just so we can call in and get this method statically, and we go get, and if the instance is equal to null, then we want to create an instance. So how do we create an instance without having, anything in the scene? So to create a normal game object, we can just go game object, name of game object equals new game object class. And this is optional, but this is the game object that you would see in your inspector. Yeah, so that's going to be what you'd see in your inspector if you looked at the hierarchy. It would name this game object game manager. So then instance, because the instance of this game manager is a game manager class. So instance equals the new object that we just created, and then we use a new method that we haven't used before. We use add component. And what type of component are we adding? We're adding a game manager component. And what parameters do we pass in? We're not going to pass in any. Don't really need to for this. So then this accesses the game object that we stored when we create that new game object we stored reference to. We add component to that game object that we have reference to, and we add a component of type game manager to that, and then this actually refers to, once this set of methods evaluates and runs, it returns actually a type of game manager. So it'll be that game component that was added to that game object. So we have the new game manager that was added to our new game object, and we store that to the instance. Now, why do we do it this way? Because I'm not going to be putting in a game manager into any of the scenes. This is meant to run by itself for its own reasons when something needs a game manager. And we'll be designing with that in mind a little bit. And then after we create that, we return our instance in the get. So we return the value of the variable, which will be that new game manager. So you might be wondering, okay, so how do we make sure we don't actually check for any, if there's more than one or any of that? Well, we didn't do that in the C# one either. What this essentially does is it makes sure that this instance is only ever created and done here. And then I left a comment here. I didn't remember to go back and do this. So we add a line here. Do not destroy on load, or don't destroy on load the new game object. So then this will keep the game object persistent. So it won't be destroyed when Unity changes scenes and does scene cleanup. This will actually be carried into the next scene with its same transform information, which is more important at a later date when we talk about moving physical location type things in. But that's not going to do too bad because Game Manager will never have a physical place that it needs to be or a physical thing that we need to render. So that's what I mean by the getter style. So you can do that style so that it always does it through the getter, but it creates a new object. And then this object itself will never be added into a scene. It will never be on a prefab or on an object in a scene. It'll be created when the game is running, not touched by the designers, which allows you to be a little more have a little more control over your code and not have to worry about what can the designer change while they're setting up their scenes and whatnot. So there's that. Now I'm probably going to switch my cam back to the document view. So the next one would be awake. We'll be using an awake. We'll also be using an awake style one. And we'll switch back and show you what that looks like. So what I call an awake style one would be where we have everything running to create the singleton in the awake method. So let's go back to the document view again and just talk about awake really quickly. So execution order. Same video I talked about the C# singleton. You'll notice I talked about execution order, although a little bit not very precisely. So if we do this, we want execution order. So what is execution order? It's just simply the order, O-R-D-E-R, in which things are executed. And we want to achieve order independent execution. Or at least as close as we can to it. Execution. This means that we want things to call as they occur rather than in specified order at every step. Not always able to be done, and sometimes not performant to be done. Sometimes it's more performant to have something that's somewhat order dependent and have other things that are order independent and just kind of mix it up that way so that we can schedule when things run. But for the most part, order independent, especially if you're PC or PlayStation, something with some power to it, Xbox, you're going to want to aim for order independent execution rather than something that is calculated unless it serves specific optimized, which I'm not sure anyone following along with these videos is necessarily gearing towards doing at current time. But we have anyone working in AR might want to pay exclusive attention to their execution order for optimization reasons, because phones don't have a lot of memory. So execution order, we have, there's a couple different ways to think about them. We have what I would describe as the built-in, again, not really necessarily the correct terms here, but they'll serve our purposes today. So you go by Unity's standard frames. They are awake, which counter runs as soon as the scene's loaded and starts any object that's in the hierarchy at this frame will run their awake. So if you spawn objects in and want them to do things, you shouldn't put things in the awake if they're being spawned after, and if they're not existing in the scene when it's time to load new scene, you don't want to use the awake. And the awake only runs once, so it only runs in the scene that it was in, which might be easier to explain in the editor. So if we go and look at Unity, and I can open mine. If we look at Unity over in the hierarchy, so this is a scene, right? And main camera, plane, capsule, player container. These will all run in awake because they're in sample scene, and they will run all on the same awake after the scene is loaded. But let's say player container, or even like that one game manager singleton I made, does not destroy on load. So it would carry over into the next scene, and it would not run a second awake because it has already run one awake method, and it will not do that again. Um, Same thing goes with start for quite a bit. So then if we move to document view again, and I can get to my document view, the next frame to run would be, or not frame necessarily, but next step would be start. Start. That's kind of the one right before the first update that everybody goes through, which I believe is the same as wake in terms of it won't be run again. So like that. So if that object were to carry over, so if this object were to carry over, it also would not run another start. Start only runs once in the scene that it existed in the hierarchy. Okay. So we have start, and what's next? So I used onEnable in that video, which turned out not to be quite right because because everything in the hierarchy will enable at roughly the same amount of time, but not necessarily at the exact same time. So there was some execution dependent things going on that really needed to be made execution independent. So there's that. And then since the goal of this game is to make it multiplayer as well, we need to think about what networked would look like. So network would look something like can we get control enter? Yes. Networked would look something like an awake. Very similar to what the standard one is. That doesn't change a whole lot. What's different is then second, instead of start, we have the something to do with the on network spawn. Yeah, and so essentially here, I don't have a thing pulled up, and we're not going to get into that part of the game development today anyway, but basically on network spawn, so you can have objects in the hierarchy. Let's go ahead and look at our hierarchy again. You can have objects in the hierarchy. They'll still run the awake, but they'll run the awake across every single client if it's in the hierarchy on a scene, because all of them have that object and all of them have an awake, so they all run that method on the awake. So there's different ways to check who owns what, and we'll go over that when we get to the network part of it. But as for right now, just know that our awake, start, and enable are not always in the same order depending on what other kinds of tools we're using or what our target is, say multiplayer or what have you. It might change a little bit depending on what our target is. So let's bring up document again and get me back on the documents on network spawn. And then you have start again. So you have awake, then you have the network spawn. So this is where objects spawn on a network server. Yes, this is a server only thing. But it runs but this is the order it runs in. So this might only happen on the server, but in terms of total execution, the server goes awake, everybody does awake, and then on network spawn, everybody technically does on network spawn, but on network spawn is only the only one that can spawn objects unless you really change that is the server, which you shouldn't change. The server should be the only one spawning objects. Even if you're trying to do some like improving the flow of gameplay or something, for the most part, this is pretty good. And their start, which is still working pretty much the same as awake. And start, same as start up here. Not too many differences that I've seen yet, but there could be some. So that's a little bit about the execution order. So I don't think I've actually went over the awake part yet. Why I use the awake one. So putting it in the getter and making it do that, we can keep it on a game object if it's a very simple game object, and we don't have to, because we can't necessarily have a prefab that we spawn in. It's going to have to be a pretty simple game object with maybe a few components that this specific getter can just say, hey, I need these game components. Whereas in awake, we can have it run, we'll look at my code here. Whereas if we do it in awake, like I did with the race manager and the game mode, game mode's going to be a little different because we need to do not just, nah, we don't really need that. But yeah, so these two will be very similar, race manager and game mode. And the reason that's done on awake, so we have this one method that we're calling, especially if you're using predefined and like methods that are event based and whatnot, having it so you just add a method. If I can, it might not be in this set of tutorials, but I really like the idea of using delegates. So if you haven't used delegates, don't worry. They're kind of difficult to get a hang of at first, but once you get a hold of them, it's pretty easy, and it just comes back to if you're not good at order independent execution programming, you're not gonna like uh, those at all. You'll actually find them even more frustrating than delta methods, which I will never use. Any rate, all I'm doing here is I use a new method that we haven't used yet. Use race hold. Don't. Okay, there we go. Race manager. Race manager array. So of a class is class name, class type, and brackets. RMS, just using initials plus S to designate multiple. And find objects of type. So we use find object of type. This actually belongs to game objects. But since it's a static class that pretty much every mono behavior has full access to anyway, because it inherits from game objects, we can or at least part of it uses parts of the same interfaces and whatnot. We can just do that because it knows what it's looking at. Race manager, so we find objects of type. We look for the type that this is, and if rms.length is greater than 1, we want to destroy this object, because while methods that run on awake tend to run at about the same time, they don't run at the exact same time. So his awake method will not run likely when the other when another one race manager will run its awake method. These are all just called on the awake of a scene. So we have that to working for us. And this just says there's not more than one, which means I can write code that requires a game manager. So it would use a get to find the game manager. The game manager would have its own public static instance that is not destroyed uh, between scenes, so it can hold all our information. Any objects we need referenced, it could have reference to so that they aren't destroyed, even if they're just regular C# classes. And then rms.length. It can't be more than one or else it's destroyed. You notice we don't use a do not destroy in here. That's because the idea of the race manager is to manage one individual race. It might manage multiple laps, but it doesn't move outside of its scene because there's no need for it to manage any more than this one game that we're in. And this is where we'd change some of our things so that designers could come in here and have settings that they can make so that they have different, say like when we go to checkpoints, they can add checkpoints to the racer because he's a physical object in this, not a physical object in the scene, but he's an object in the hierarchy that they can go in, reference, and change, and it's saved. Or they can make prefabs for different stages, do it that way. But this is generally what we're looking at. We don't want it to exist in other scenes. We just want to make sure that there's only one in this scene. So for example, that'd be like if we had in Unity, say this is our race scene, right? So the race manager would be in here to keep track of our player moving around in laps, doing laps, where he's placed, where all the players are placing being the if they're in first, second, third, etc. Keeping track of that, and then maybe either we put something, either make game mode last for longer so that it goes with the scene, or possibly not, but that'd be something to look into. I'll look into as I'm building the rest of the structure. Like one of the things moving forward, stuff like this, I'll talk over, but I'm not going to do live demonstration on as programming this because it's just when you start playing around with the scene management, update frames, awakes, all those sort of things. Unless you're doing something really basic, it's really, even when you're doing something really basic, it's easy to screw it up. It's not one of those things that's all that easy because you have to keep everything order independent, but you also have to keep things referenceable, or else you'll get null pointer exceptions. And as my friend told me, there's just too many of those in the world. So we'll look at these and we'll probably revisit these several times as we keep going. Which brings us back to, so that covers our singleton, and I need to bring you back to the document view. Brings us through singleton section, execution order. We talked about that. It's very important to keep things independent. We have things to think about, like built in the normal frames that we work through. I call them frames just because I think of them in like a storyboard. This frame awake, start frame, setting, and enable frame. Which for enable really isn't a great way to think about it after starting, because everything has enables later too, but it's not a big a deal. And when we move into networking, we get awake, on spawn, we get start, and we keep going. Um, that's all covered. The next thing we need to talk about is controls. Controls. So a majority of what I'll probably be moving on with, when I do live codes things, they'll probably be pertaining to controls. Controls meaning like movement, the state machine, other things that I've practiced a little bit more. We'll cover instantiation. So like one thing I want to do as part of this game is probably going to revolve around shooting. So there will be a shooting mechanic. Probably not the way that jumps to your mind, like constant machine guns and um, whatnot, because I say that because that is indeed one of the first things that came to my mind is how do we not do that? How do we actually make the mechanic of shooting that is not turning it into a GTA like shooter? Um, I mean shooter loosely, any game with a gun, but you know, there's that. Um, Shooting is one thing. I'm talking about another state machine. It'll be much smaller. That first setting up of the movement states was a lot for. I'm sure it was a lot for some new programmers. Uh, Little sorry about that. But it was kind of necessary to get our the spider web of uh, our kind of web of structure, if you will. Shooting controls would also pertain to is ground, which will be a simpler state machine. So if you struggled with that, um, the previous state machine that's the person controller, and you kind of like, okay, I type the things in, and I'm not entirely sold. I know what I mean. What I mean when I talk about this thing. That's perfectly fine. This should help a little bit clear up anything that you were thinking about, because is ground, we got two, maybe three states. It'll be short. Then we have layers. We'll get into layers. Uh, we'll get into layers, specifically checking for the ground layer. We'll go through how layers work. Notes. Uh, I have a preference of layers. I have a preference of not using tags at all. And I have a preference of I had weird issues with the layer system. Not necessarily the layer system itself. Layer system worked fine. Getting the layer worked fine. Something about layer masks didn't quite work right. So 2019 to 2022, note is that don't use. I can't type very well, so sometimes I'll skip those extra punctuation marks. Layers don't use layer mask. Uh, Layer mask, and I'll put that in parentheses, conditional. So, and why is that conditional? So, when we get into like physics, raycast, spherecast, that sort of thing, okay, yeah, you're gonna need a layer mask sometimes to either ignore or look for a certain layer. It can, if you have to use a layer mask, you need to use a layer mask. If you don't need to specifically use a layer mask, a lot of layer masks are equal to integers. So When we look at layers, I'll show you they have numbers that they correspond to. 0 through 31, pretty close to that, because it's an array of 32, so 0 to 31, I'm pretty sure. And you can use that integer, and you can leave that settable for the designers. They can go in and say, hey, this layer's on here, or hey, we had to move this layer to here, so let's put an integer in here. It's a lot easier if the designers can just know how to use layers via integers, and then you leave openings in your code, or not openings, like parameters, like serialized fields for them to add integers into to change how their uh, layer masking and layer collisions work, rather than trying to do it all through code and use layer masks in your serialized fields. And it's just easier to use integers sometimes, most times actually. Uh, that might have changed with the new 2020, the newest version of 2022, and it might change in 2023. But as of my experience, use integers whenever possible and avoid layer masks unless you can't. Okay. So, serialized array. We're going to use an array of I'll probably just save that point for when I'm working on the layers, actually. I enumerators for state. We're not going to use that. Cool. That was just a note I had for myself that I thought we might use, but after thinking about it for like more than 20 minutes, it was going to brick everything, so we're not going to do that. The state machine is complicated enough without changing it to be using enumerators and whatnot. But I can show you what one is when we go over the ground check. We won't use it, but I'll show you what one is. Shooting. And that should be the good gist of it. Shooting will have two more patterns. We'll have factory, we'll have not observer, what is it? It's reusable object pooling. And Unity does have a built-in for this, for object pooling, but I don't POING, maybe, I don't know. I can't spell. Factory and pooling. Unity has its own pooling, but I prefer to customize it a little bit. Especially since it really works with objects. It might be more performant than what I'm going to show you, but I like being able to see a lot of this stuff, and I don't quite like I like being able to combine my factory and my pooling together. Not in the same class, of course, but I like to be able to combine the two functions without having to worry about the pooling necessarily. Also, there's a lot to remember when you're setting up Unity's object pooling. I just prefer to remember if it's not within 5 lines or at least 5 methods, I am not going to retain it. I'd have to keep notes with me at all times, and I don't use object pooling except when I make stuff like shooting or a random spawning type stuff. Like if I was creating an enemy spawner, I would have a factory that has like a zombie to it, and I would have pooling where that zombie would be pooled when it's destroyed instead of destroying the object, which we'll get into. but I pretty much use it exclusively for uh, shooting, gun type things, and monsters. I don't use it, or enemies. I do not use it outside of that too often. Um, but those are two really simple things that are good for any level programmer to know. You think about someone who's brand new, it's like I get the initial movement system with the state machine might have been a little rough, but these two are very easy and shouldn't require um, should be very easy for new people to learn. It's just getting used to thinking in that uh, where where did I scroll to? It's just getting used to thinking in that cyclical programming uh, design. Networks awake. So we have covered all these. So yeah, I'm gonna focus more on the controls if I'm doing live coding, and then as I'm going through, I'm gonna try and have certain things on, like um, certain things like our singletons, our game structure, changing scenes, that sort of thing is I'm gonna try and keep separate so that I can focus on it and not be focusing on camera and code, because it's just I just like you saw in the one video, it doesn't make for a good video. I'm thinking about too many things too deeply, and it's just gonna get confusing. I do need to check a quick thing. So we're looking at the quick thing. Okay, all good. Everything looks good. Might be falling apart, but nothing says no. So, on to the next part. We can look into our do 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 do. Um, we can look into some more controls. One I think I want to look at is possibly setting up dash and playing around in acceleration a little bit. I think that'll be fun. So why don't I close the announcements book and move back over to the code. So I'll save this up. And you can always go back in the video and pause and look at the code. So here's a wake. Here's a single race manager. There's your two things that you need to see. So there's a pause and an unpause. So let's go to, and then I'll just do the same thing on game mode real quick. Can't quite fit it all in frame, but game mode, awake, single race manager. And the game manager, we have instance, make the spinny rotating wheel. Oh, rotating wheel would be a good one too, though. We'll do rotating wheels today. Rotating wheels sound fun because it'd be nice. It would be a nice spin on the game. um, yeah, a very nice spin on the game. So if we have instance null, okay, here's game manager. This is our getter. So getter, make the spinny wheel spin. It spins and it spins and it spins and it spins. And okay. So what I'll first do is go back to the Unity and just kind of look at what we need. We have our game manager, game mode. This is all in game management and scripts. I need to move the racer one in here, but you see the nope. Okay, I need to move the other one that's inside COs. That's fine, because we're not going to use that as a scriptable object, because then we have to have 5 or more of them. That's dumb. Racer input. So what do we have? Game manager, racer move, game manager. So what's if we want to make a rotating wheel? Okay. Don't have any of those scripts yet, right? Where would we put those? We won't put that in any of this stuff. Scriptable parameters, nope. Racer movement, you could put it in there. Not really into that type of thing. Scripts. But it should be in script. Argument could be made for putting it in animation, but what I would do is I'd put scripts and I'd create a folder. Left click, right click, create. What is it? C# script. No, folder. Create a folder, and what do I want to name this? I'm probably gonna. A little bit of a cough. Hold on a sec. Okay. Yep, better. Oh, and I clicked off of it. Rename. Let's call this our animation scripts folder. So animations here. So let's double click open animation. So our scripts, our animation scripts. And why would I do this? When we get into complex character animation, you're gonna want this folder. Create C# script. Let's just call it what it is. This is a wheel rotation. And that's 2 words, so capitalize one of them. Rotation. And we wait for that to compile and open on the code screen, which it has. Pop the code up. What's the date? We do a /e/. We do an 8.6. Not 86. 8/6. Do. We got that. We get rid of our start and our update because we don't use those. Not right now. Well, actually, we probably would have used our update, but whatever. We're going to use vars. We're going to use methods. We're going to use accessors, maybe. We might not. It's yeah. We might not use accessors, but we'll see how we end up. We got a bit more wheel rotation. Okay, so variables, what do we need? We need a transform to rotate. That's all. Wheel rotation, we gotta decide what level we want it at. Let's go back to our Unity and look at our levels. We have player container, we have player body. Player body is where our rigid body is. So we're not rotating this. No. Player body is what we are rotating. Body flip is just to make our things look nice. Player body is, yeah, just a container for all of this stuff that is flipped. So we don't want to rotate all the stuff. We want specifically the wheels, which I still have box colliders on there. This is a, you know, this is a tutorial. If you want to put capsule colliders on them or something, feel free to. I'm just going to use the basic colliders for demonstration purposes. They're easy to deal with. So these two are wheels. Why do I have that? Oh, colliders are underneath. Okay, so these are oh no. Easy fix. So I have these colliders under here. And in order to rotate the wheels, I have to rotate the visible object, which is this. So we don't want the collider to turn with it, because then we have rectangles turning and knocking us from the ground when they should be circular. Easy fix though, we just take and this collider objects, because that's what it's on. These collider objects are in the correct spot, right? So we just go beep up to body flip, and we take the right wheel collider and do the same thing. Beep up to body flip. So now these are in the position the wheel will always be, and it's not dependent on the wheel's rotation anymore. So then we can get the wheel. I just kind of wanted to see it. Okay. You can turn off the view of the thing somehow. Toggle gizmos on. There we go. I'm just gonna toggle the 3D icon off for right now. So it doesn't show on yours because it's pop-up window, but this this gizmos here, you click the arrow down, and the first one, 3D icons. I don't really want that icon that big, and it just kind of made it smaller. So that's our player input icon, just saying, hey, this thing here has a player input. You might want to be aware of that. But it was just so big it was interfering with me seeing the wheel, which when you're doing wheel rotation is terrible. So now let's do a wheel. Okay, so what layer would we want this on? We can either reference the wheel out to the top level, or we can put one that goes directly on this wheel. I would vote for the prior, because I want one. If I have one script, it can turn both of these at the same time based on its velocity, which is what I'm thinking I'm going to do. And if I have that kind of going on, it might be useful to have the wheels turn at different rates, like if I'm taking a corner or something. But this is an arcade racer, and it's there's two wheels. It'd be cool to maybe slow one a little bit, but it's not that important to the overall game look and feel. So we'll just make sure it spins at speed as it goes. So let's go ahead and make sure we're going to put it here, okay? So let's pop back to code. Look at the code. Look at that beautiful empty code. It so doesn't do anything. So first thing would be I want a designer to be able to influence how fast this actually rotates, um, and what direction it rotates, because I don't know what these wheels are, and I don't know what the objects that they bring in will have for rotation. I don't necessarily want to go in on this specific wheel object and alter it in any way to. It's actually got a zeroed rotation, so not bad. But you never know what objects are going to come in at, and you never know when you're going to need to provide a fix that Unity didn't account for. Uh, Primarily unknown import settings. So we'll just do something that's a little more difficult, but overall it'll help us rotate anything else we also need to rotate later. Say you add a helicopter to the game to like drive by in certain parts of the stages or whatnot, or just a fan in the stage that you have to not slow down, because we don't do that on this game. We just accelerate. That you need to miss the blade as you go through a part of the course or something, if you have a junkyard asset that you can use. Something like that. You get really miniature golf on this arcade racer. Uh so what do we need? We need a do we want a region? We're not go This isn't gonna be a huge script. So I don't really want to. Uh Plus I'm sleepy, so I throw out some of the best practice. Except for the part where I'll probably serialize field, except I'll probably give this a header, because headers and tooltips are your best friend when you're designing for designers, because they don't want to read documentation, nor are they always given time to read documentation, to be honest. Uh, I remember I had that was when Netcode for Game Objects first came out. I looked at it and I'm like, it's kind of difficult. Maybe I'll try one of these other ones, and I couldn't get a scene to start. I think I started with Photon. I think I started with Photon, and after it took me like I'm like, this is taking a long time for netcode for game objects. I spent like 2 days on it, and I'm like, I still barely networked like shooting a marble, and I thought, well, maybe I'll try Photon, and I spent 5 days because it was supposed to be better for like PvP type things. I spent 5 days trying to program it. I couldn't get more than one player to spawn, and I'm like, I had this game like half of the structure down. Um, it was just I just couldn't get that specific tool, so I moved on. I used a different one. Um, that's kind of what designers will do. They won't read it fully. They'll look at something, or yeah, I mean, if coders do that, the program designers are going to do the same thing. They're going to be like, I mean, this looks this way, so I should probably do this, and most people will do that instead of trying to read through a bunch of documentation, because it's a lot. That's why in a lot of documentation I've seen recently, it's like, take the prefab, unpack it completely, and then use it for reference. And it's like, yeah, it just does. There's so many moving parts on some of this that we need to use things like headers. So header, because we need to label things, and we need to let people know what they need to be using and what needs to be entered where, because your little variable names come up, but that's not always useful. The most useful thing they could have. So we got serialized field header, and this is going to be a wheel rotation. So let's call this rotation direction. rotation direction. I'm sure programmers have, if you started out programming, it's you do a class and it's either really laid back and it's really flowy, or it's a little rushed, and so you might not be able to. People want you to do a bunch of reading, and I for one don't have a great reading speed, so whenever somebody is like huge reading assignments, I'm like, that's a whole day if I read it. So you might read half, or you might read parts, or you might read it in shifts, and it's just we need to make things as programmers that make things easier to be made. That's the main thing. We don't only make things that work, but make things that are expandable and alterable, and most of all usable. I've heard Twitter's a pretty good recent case of this, where it's becoming less and less usable. I know I've had plenty of experience with doing some demo stuff with the Oculus Quest that not always the most usable interface in terms of just even setting up the device sometimes. Direction, serialized field header, rotation direction. So let's call this rot direction. And this is actually a pretty fun thing I looked at. I really like this. You just have this bracket that you see before, and you can put serialized field header. You can put a bunch of other things in there too, and it's just really nice. Rotation, to have that in one tag rather than what I used to do, which was have 3 or 4 of them preceding one variable, which kind of sucks. Rot direction. Don't forget our access type, which will be protected. Mustache is getting a bit itchy. Protected rotation direction, and that'll be a type of vector. I might still new line this, yeah. Rot direction. It's a vector 3. Let's give it a value. We don't care what the value is, so we do vector 3. Dot is 1. Vector 3, 1. Difference between this is one like 0, but instead of vector 3, that is zeros, so 0, 0, 0. This is vector 1, 1, 1, which is why it's vector 1. So basically, this will rotate. The idea between this is we have a vector 3 where the designer can tell us what axis it rotates on simply by editing in vector direction x, y, z. So x, y, or z, or on multiple axes, or a fractioned axis. So say like we have to go, I want to split x and z or something. I want to rotate it on x and z, but not y or something. You can set all that up here. So, protected. Let's do a serialized field, because not all of our objects are going to be rotated on z, y, or x, and it's just nice to have that there. Which we could probably rename this not wheel rotation, so that we know it's just something like object rotation, maybe. I don't know if Unity uses that name though or not. Of course, they might use this name too. But their namespace separated, so they're fine. It would have told me in this IDE, because it does pretty good at it. Serialized field. I want header. And what is this dude here? This is going to be our rotatable AT rotates able. If you're not sure, just change the words you use. Body to rotate. At a certain point, you'll probably notice, hey, programming, people talk about it being a lot of math. There's certainly things you can program that require a lot of math. Web design, not necessarily one of them, depending on the web page, part of the web design you're working on. Some of them might, but I haven't had to worry about too much following heaps versus that sort of things yet. Protected. That's not quaternion. That autocomplete's terrible for that. So this is going to be a body to rotate. So this is going to be our transform, the thing we're rotating. Because I don't want to store the whole reference to the whole other object. So we'll call this bod tf. We got bod tf. That's equal to null. So don't declare. I do not declare. But we go on to the other methods. So we have serialized header, body rotate, and we have rotation direction. Now what do we do? The only thing left to do is to apply rotation based CTOR vector 3. And that's still a lie, because how fast are we rotating? We don't want him to go in here and put like, okay, 40. So it'd be like 0, 40, 0. That doesn't make any sense. So probably what we'll do here is, even though we put in 1, what else can we put in here? Could try. Can we do a comma? Can we do a tooltip? And basically, I think this is just a string, isn't it? Yes. Tooltip. And put in this. Value will be normalized. And we can either normalize or clamp it. I'm just going to normalize it because there'll still be 1 forward 0 0. Yeah, so this value this value will be not clamped, will be normalized. And then let's reduced to 1. Just in case I don't know what normalization is. So then header that we've seen before So we have serialized field and header that we've seen before. We have tooltip, which is new, and we'll see that when we go into the inspector. We have serialized fields, body TF. And what's the last thing we need? We need some serialized field. Whoops. Header. And what's this one gonna be? This one's gonna be very fast. It's gonna be da 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 da. I just need to check one more thing. And checking back. So we have serialized field, header, body to rotate. This is going to be the speed of rotation. Which we don't really want to do. Well, we can actually. Yeah, let's do. Because that's all in one class, we can just use it as a rotation class. So. Speed of rotation. And this will be a protected int. So an int, no. It would be a float. Well, a float, because vector 3 can't be multiplied by int. It can only be int multiplied by a float. Float, and this is not capital. Rot speed. And declare it equal to 0. Let's add a range in here. Range. And I don't want this to be, I don't want it to be lower than 0. I don't want it to be greater than, let's say 200 hard cap. Why 200? Unity update when running as fast as it can on a computer that's running it as fast as it can possibly be processed. It runs about 200 frames. So 200. We don't want it running more than 200 degrees or something in rotation. Okay. And then that header's probably good. We don't necessarily need a tooltip, but we could put one down here if we felt like we needed to. Methods. That kind of depends on your design environment. What kind of designers you got working there? Have they worked in this before? Are the headers going to be enough for them, or do we need this? If you're selling stuff, it's pretty recommended that you put tooltips in on your fields, pretty much all of them, because when you buy, if you buy one that because you're not specifically working with the team usually if you're selling assets, so a header is rarely enough information. They could kind of use a tooltip with a description to help them out. Just in case there's any things that you want to disclose specifically as well. But apply rotation. So basically, we might only get through the rotation tonight, but that's okay. Wait for compiling. So, take a drink. Okay. So we apply a rotation. What do we want? We want rotation. So we need a public or protected method. It depends on us. What do we want a protected method to be? Protected. So if it's protected, nobody else can call it. Which is fine, because this is just going to run on update every frame anyway. So we go protected. Rotates. Bod. That's what I'm going to do, actually. I'm going to go and rename it. Object body rotation. Oh no, it changed that. Okay. Come on. OBJECT. Object body rotation. And I don't like that it changed this, but I'm just gonna have to retype it. Which this is gonna be rotate body objects. Rotate body objects. That's gonna be a void. Because I don't really want to return anything. Much like some service counters, I do not want to return anything. We got protected rotate body objects. I saved, so it's compiling again. We got rotate body. So we want to do it at a rotate speed. So first I'm going to do if rot speed. If rot speed. I'm not going to go is less than 0 because it can't be less than 0. I don't want to do greater than 0 because it's a float. They're not super accurate. Although they're accurate on like there's a weird thing I heard when they were talking about floats. Floating points aren't exact, but they're reliably exact on fractions, on all integers up to a certain point, and all fractions with powers of 2 in the denominator up to a certain point. It's weird. The best way to think about it is to just not and say they're not reliable. So if it's greater than 1, I'm going to say. Because nobody is going to go in there and say, hey, I want a rotation speed of 1. Yeah, sure. Sure you do. Uh-huh. So, because 1 by a normalized vector is going to be rotating 1 little bitty degree. And if you're not, this is meant to be more spinny. More spin to my win here. So 1's good enough. Anything above 1, that's what they actually meant to set it. So if rotation speed is greater than 1, then then I'm going to do something different, which is going to be to rotate this much, which is going to be body TF, bod TF, dot rotate dot rotate the rotation direction, yes. And that's going to be multiplied rotate direction multiplied by rotation speed. And why is that giving us a problem? Because that's not supposed to be here. That's better. Because rotate is the function that's rotating by a vector 3. The vector 3 is what I wanted to multiply by our rotation speed. So designer enters a rotation direction that's normalized by rotation speed. And this value will be normalized. Will be normalizes? No. Will be normalized. Duh. And to make it normalized, I'm just gonna, and I used lowercase normalize, which returns a value. Why is this not recognized? Oh, it's used the other way. Okay. Control X, Control V, but the reason it's a, and this is part of the static class. So I'm actually going to go in vector 3 dot normalize. So it's a static method. So I can use it from just referencing the class, because vector 3 is a struct, which is static-ish. But I can reference this from the vector 3 struct. We'll look at structs maybe when we get to networking, and why I find another reason I like netcode for game objects, because I don't have to create my own structs and send them over the network, and a lot less hassle. Serializing isn't a big deal. Just use normal serializable types and you're fine. But structs are different than classes. Think of structs as a collection, not a collection, where classes can have nulls. Structs must have a value. So it's like an object where it can have multiple variables and methods, obviously, but those methods and variables must contain values. Cannot be empty, cannot be null. And for that reason, they're more serializable, but they sit on the stack differently, which is a term you'll hear about. But on that stack, they sit differently and read differently than objects. We'll probably talk more about that getting closer to networking for game objects than we will through the rest of this, getting the movement and stuff working. And again, that's why we're avoiding awake methods, start methods, and stuff, is because we're planning to pull as much as we can and inherit as much as we can out of these existing classes we have into the new netcode for game objects, with just using a little bit of adapting. So we have rot speed, and we have body.rotate vector 3.normalize. We have rotter, and we have rot speed. So that's great if it's over. If we want a consistent speed, all we have to do is change this to be greater than 1. Great, easy. I'm looking at this and there is one bitty problem. If we wanted to eventually do something different with the rotation direction, um, this being normalized, well, using this normalize here, this way. Okay. It normalizes it so that this vector can indeed not have a value of greater than 1 in any of the things, right? Does that cause a problem? Well, it causes a problem in the terms that it alters an object. Not that we really need to worry about that, but changing a value instead of just getting that dot normalize might be a problem later. And just to avoid that, I'm going to decide against dot normalize actually in this instance. It'd be different if I was getting an object, like getting a value, then normalizing it, and then doing something, but since this isn't an entered value and I just want that, I'm not creating it, I'm just using somebody else's, I feel more comfortable referencing it than I do changing it, if that makes sense. It's more of a comfort thing and a consistency thing where this rotation direction is constant, or not constant but consistent, rather than being changed into a different vector. I just don't like that. So I'm going to use that actually, dot normalize, just for personal preference. Because to keep normalizing it, every time you normalize it, you also set it, and that can also possibly be more expensive than getting a returned normalized value. So we do else. Not that I know if it does or not, but it leaves the option for that to be possible. So I'd rather not. Or for it to be set and I actually end up needing it at some point, so I just don't want to touch it. So we can pretty much just copy paste this one. With the exception of rot speed. So this be the transform. And this is something I started doing. Let me first check. Okay, so like in awake, a lot of these methods go and get their setup type stuff. Now I lost what I was working on. Object rotation. Okay. In awake, a lot of these methods have been going and getting their stuff, so I'm probably going to continue that here. Especially, no. I'm just gonna smooth over here and I wanna check out erase remove context. Because this runs SD# in creation. This is run on enable, so I'm using on enable so I can, yeah, okay. That was my worry. So, yeah, on enable's fine currently. And everything we do on enable on these will probably move into on network spawn. And that's just because of execution order. Because on enable it actually always runs after like start, so it would be awake spawn and then enable. So we'd actually, when we make the network one, we do it on network spawn, and we cancel out what our enable is. So actually, one good thing to do here would be to separate this out quickly, and I'll probably put that underneath. So it'd be protected, void, fixed, no, and I want setup here, right? So let's just call it setup bars. No, setup bars. No. This is the point where I use. If you start doing this type of stuff, you should probably shut off your computer and go to bed. Setup bars. We're gonna go grab the thing. We're gonna copy the thing. We're gonna paste the thing. We're gonna select the thing again. We'll delete the thing. And we'll paste the thing. The reason I'm moving it to setup is then, oh, this is a private on enable. Okay, cool. So later when we don't need this enable anymore, it'll be private, so this class won't share it with anything that inherits from it. Same with the update. But we'll have setup vars, which we can protected, virtual. So we'll be able to inherit this later and use this for our networking type stuff, which is great. So what do I want to do then? We're there. We're almost done with the object rotation. We'll probably finish object rotation and then shut down for the day. Do some quick recap stuff. Ending announcements. Methods, apply rotation. So then we have rotate at that direction, dot normalized. So on enable. Let's start with an on enable and then move from there. Let's put it before applying rotation. So PR I private on enable. I don't want to get the transform component. What I want to get is I want to get the rigid body reference. And we're talking about putting it on the top level, which would be player bod where the rigid body is. So we can just get that. Before we get that, we have to get here, and we have to do, I'm just going to go protected. And what would this be? This would be a protected rigid body, RIDG, RI, rigid body, rigid body, rigid body, or is that rigid, RIGI? I'm not good with English, let alone English. On enable, we have the rigid body. So our RB is going to be equal to get component of rigid body. Ba-ba-da-da, all done. Enable for an object in the scene store runs before update. Enable has to run before it runs its first update. So we're all clear on that. I would create a setup method, but I mean, honestly, it's one line. It's pointless to do that. Unless you're thinking about having it do setup halfway through or something. This is fine. Rotate body object. So then normalized, and I want to multiply that by our should be familiar rigid body dot velocity and velocity is the three directional vector 3 dot magnitude which will return effectively about how fast the vehicle is moving, which in the air, not the greatest, but that's fine. We could probably change this to reference something so that it knows if it's on ground or not, but we could also separate this out into one for objects and one for players, where the player one is like, it's moving at this velocity. We do basically this, but that it only runs when we're on the ground or something like that. Of course, if you're in the ground or if you're off the ground and you haven't hit the ground yet, right? Your tires are still spinning because not you're still on the gas because you want your tires spinning when you land so that they carry you through. So it goes zoom and not boom, stop, force the tires to roll because that's not great. So this is still probably fine for that. Again, it's going to be a bit arcadey so anyway, so it's not going to detract from our charm or our style at all. But we'll just do that. So if our speed is if our speed is greater than 1, it does this. Otherwise, it uses the magnitude, which is cool. Means I can use this for multiple objects. Means this shouldn't run if there's no rigid body that it's supposed to be following, because that's the kind of dichotomy that we've set up here. We want to use that velocity if we're not supposed to move at a set speed, and type your namespace and file extension expected object body rotation. We have too many brackets. Something while I was typing just added that extra bracket. So, or I did by accident. Let's reload Unity, or save and let it recompile anyway. Okay, then we're testing and we're moving on. So, hide the code. We'll hide the code. Like any good programmer, our code is completely hidden now. No. So I want to go to the player bot, I want to add component, I want to add the object body rotation, and we got a bod TF. And actually looking at, well, we'll test it with one wheel and then we'll change it to 2 multiple wheels, or if anybody's feeling comfortable enough to program it, they can go ahead and do it on their own, and we'll revisit it next session. But let's just test the one wheel. So, because there is a very quick way to change it so that it rotates multiple objects based on one thing, but we'll leave that for if somebody wants a challenge. And also then we can just move on to something else. So the transform, one of these is a wheel. That was 01. So that's our left wheel. So we pay attention to our left wheel. And our thing's set at 111. Speed set at 0. Should hit play and it should start. Da, 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 da. Oh crap, and this is where our scene view needs to be separate from our game view, because we need to be able to view set it up for what happened? Is my input connected? Is my hold on. Let's go check our idle. I think what happened is I set it up. I took away the 4-directional thing, thinking I was done with that testing. And I don't. Yeah, I removed it. I removed the move information and accelerate. Okay, so what I'm gonna do, not recommended for most times. Let's put it in the body flip. And then I need a rotation. I'm just gonna do this for something like that. We'll do this for temporary. This is not how we set up the camera at all. This is a test. And we're just gonna be specifically looking at the wheel. Does it spin? And it doesn't. So why doesn't it spin? Do, 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 do. So we look at our player body, our rigid body. It would be cool if we could see our velocity in here. You'll see we are coming up. He's still going straight, and then he finally goes off the edge. Okay, so what causes that not to work? Well, we got player bod. Let's make sure my code is what I wanted. So if our rot speed is over 1, then it does that. Velocity magnitude. Can we do multiply by 50 maybe? Let's see, wait. So 1 degree. 1 degree, right? It'd be 1 degree Z. So what's our... Oh, it might also be rotating too fast. So we pull back the code. Which just might also just be something I have to fix before the next one. Being that it's almost 10 to. Which is fine. We went over more singleton stuff today. A little more concept type things, which is fine. Rotate, normalize, rigid body magnitude. This might be too slow, being that it's by 25, so factor normalized, which would be ones. Velocity magnitude. So what's our magnitude? Our magnitude would be a maximum of 12-ish. So that's what we kind of set as our max speed to be accelerating in. So we can rotate a maximum of 12 degrees a frame. 12 degrees a frame, like I said, there's 200 of those. So we might also want to add in time dot delta time as something to multiply by, because this is the time that is time since it was time since it took to take the last frame and process it. So this is running 200 times a second. It'll be 1/200th of a second. I'm gonna save and test that, and then I'll flip the displays. As H, and still no rotation on the wheel. So why would that be? That did save. X, I want 0. Y, I want 0. Z, I want 0. So let's add a debug. TF body. I added the body. The rigid body's on here, and it gets it on enable. And somebody might have actually noticed that already. If you didn't notice by now, I forgot one very important thing. I defined, and this is very important for programming. Once you define a method that does a very specific thing and you want it to do that special thing, it kind of has to be called at some point. So we want a private, come on, private, private. We want a private update, update. Private void update using the Unity event of update. Sometimes autocomplete is not your friend. There. So we want to call that every update frame, which is why we have all of this time.delta time. This should probably also be up here. I'm not going to test it tonight, but I'm just going to assume if this works, this will work too. And if it doesn't, I'll troubleshoot it later when I eventually use this. Yeah. So I'm going to test this, and then I'll shift if it works. Well, it rotates. Okay. So let's switch back and show you what happened. So I forgot my axes. So z-axis rotates this way. I want to rotate that way, and that red line means x. So I need to rotate x direction, not z direction. So all we have to do is go in here in 0 and go in here in 1. And that should fix the problem that I just had. After we get all this done, we might actually either alter this part here or just add a variable that's speed mult, so that this can be a constant speed if you want to do that, or the other one can be a other thing. But let's view that, how that works currently. So you notice the camera keeps with it. This isn't the ideal way we'll do this. You'll notice it's going X. That's rotating this way. That's not necessarily what we want. That's because it was inverted, so we flipped it before. But it's spinning that way. It's spinning really slow. So like we could add a multiplier, which I'll probably do that before I sign off today. But for the video purposes and stream purposes, I think this is where I'll end this today. So it's running, it's working, it needs some tweaking to make it prettier, but it runs in a direction, which is more than some people ever get. So, yeah, baby steps. So let's look back at the document. Let's go back to the doc. What do we have left on the doc? So quick talk about stream times. I think we're going to leave this one art. So 10 a.m. Saturday will continue to be art. 6 p.m. Tuesday, Thursday will continue to be code. And once in a while, like this Thursday, we are having a PC assembly that I believe we're still on for. And video of that will be up on the channel afterwards, but we'll be doing a live PC install with a Ryzen chipset, making a tower, setting it up. I'm not sure what he has chosen for operating system yet, but that should be this Thursday. And we might mix up a little bit and start changing some of these to be like Tuesdays this, we might change Tuesday, Thursday up a little bit once in a while to get some different types of videos and stuff for the channel, as well as stream content for the streams, and just kind of overall continue to troubleshoot some things that are either problematic or just not quite working the way I wanted them to, or would make it work just better overall, improve channel and whatnot. So that's been this Tuesday. Next Thursday, or this Thursday, will be the PC assembly video and stream at 6 on Thursday. And then 10 a.m. Saturday CST is more art things. I'm thinking on doing some. I might show you a peek of what I'm working on, how I'm using how I'll be using the same code that's in this demo to make a, maybe not, maybe show is the wrong word, but show, kind of like what my approach to making new art for this type of thing is. Maybe we'll go through some of the other object types and talk about materials a little bit more. But for the most part, I think it's just going to be me in the design software again, just Affinity Photo, because maybe finishing up that sketch or inking that drawing that page, and then maybe talking about some games type stuff, maybe doing backdrops or something. We'll work it out. So 10 a.m. we'll be discussing on Saturday. We'll be discussing art, but if you're interested in building a PC or just knowing how to build a PC, I really recommend watching that stream. And if you can't make the stream, definitely check out that video. It's a great. It's gonna be a great time. Uh, and as always, please subscribe if you're enjoying the videos. Even if some of them stumble a little bit, like the first time I tried to develop that singleton. Um, I've done videos and stuff, but I just wanted to start trying as a stream, both so I had more time to, it's a bit more straightforward when you're going through it in a stream because there's no cuts, there's no stops, but also so that people could ask questions live if they drop in, so that it can be a little more give and take and that sort of thing. And the subscription really helps. Um, it will help me produce more videos and get those things going a little more consistently. Uh, as well as like and subscribe. So if you enjoy the content or if you find the videos helpful, let me know if there's any things that people would like to see covered. Like I think I have lighting and stuff up here, but triggers will cover in this one, as well as I'm gonna try and get a poll up soon for what the next. I'll probably start that when we go into multiplayer. Start a poll for what style of game you would like to see next. Currently, it's between platform fighter and I forget what else is on the list, but platform fighter's on the list. Art direction's not quite figured out yet, but we'll get to that. Probably be between platform fighter and shooter. Not shooter. Nah. Anyone can show you how to do a platform shooter. I'm more focused on how do we best use the different objects to make different types of controls. So that's what I kind of want to focus on for this. Anyway, ping pong game might be coming soon, which would be an easy one for people to pick up, and that would also be just solo player. Might use some different kinds of network stuff on that, not multiplayer, but just network in general. Unity networking features. So that's the plan. That's a bit over time, and I'll see you on the next one.